Okay, so we left off with these two terms that are going to be needing a partial fraction decomposition. So for the first one, you will notice that it's going to have s twice and s plus 3. So we're going to have 4s squared over s squared times s plus 3, decomposing into a over s plus b over s plus 3. Could be there, but let's instead go with s squared. Should I find my eraser? All right, so again, that's an s squared. And then a c over the s plus 3. Rather than going through the boring process of partial fractions, let's just say that a calculates out to be -1/9, b calculates out to be +1/3, and c calculates out to be 37/9. In a similar fashion, we have to do partial fractions for the other as well. So that's a -2s minus 1 over s squared times s plus 3. Good news is it breaks down exactly the same way, and that will always happen in these problems. So we end up with this, but that time around, we get a brand new value of a, b, and c. This time around, the a is equal to -5/9. The b is equal to, looks like -1/3. And the c number is equal to +1/3. So now we can go in and rewrite our big Y of s using these numbers here. So big Y of s will first have a -1/9 times 1 over s plus a 1/3 1 over s squared plus a 37/9 times 1 over s plus 3. And then that second term breaks down into -5/9. The 1 over s minus the 1/3, the 1 over s squared, plus 1/3, 1 over s plus 3. But this whole partial fraction decomposition is times that e to the -2s. So again, that right there is going to be our partial fractions for the first term. And just to kind of highlight this first term here is captured by these three terms here. And then this term here is captured by this term there. So our next step is going to be to go in and take the inverse Laplace transform of this.